10.4, perimeter and area of similar figures. So first thing we have to think about is, what are similar figures? We've defined those earlier in the year when we did similar triangles. Hopefully you can recall that similar figures are polygons that have the same shape, meaning corresponding angles have to be congruent, but are not necessarily the same size. But maybe add to this, corresponding sides are always proportional. When it comes to similar figures, perimeter and area are always in a very specific ratio between the two figures that are similar. So we talked when we originally did similarity that we have what's called a similarity ratio, and if that ratio is A to B, then the ratio of their perimeters is the exact same. Because when you set up a similarity ratio, you're always using side lengths, one off of each of the polygons. So now when you look at perimeters, since perimeters are just side lengths added together, the ratios would be the exact same. When you get to finding the ratio of areas, now that ratio is always that similarity ratio squared. So that's something that you are definitely going to have to remember, work on studying that so that you can recall it whenever it is needed. So number 4, we've got two trapezoids that are similar to each other. The ratio of the lengths of the corresponding sides is 8 to 12. We could either be given that fraction, or it could just be given to us in the picture as it is as well here. So if our job is to find the ratio, now smaller to larger, so the order is dictated for us of the perimeters first. So we have to remember back to just above here, the ratio of perimeters is the same thing as the similarity ratio. So if I want to work on finding the similarity ratio or the ratio of perimeters, first thing I'm going to do is take two side lengths that are corresponding, one off of each of the polygons, and set them in a ratio. Here again, smaller over larger because we're told the order specifically. Now, because this is a fraction, the ratio is just a fraction, we always have to reduce it. So in this case, that ratio when we reduce is 2/3, and that ratio, when it's been reduced, is what we've always called the similarity ratio. So not only did we find the ratio of perimeters for part A, but we also have figured out what that similarity ratio is, again, because those two are always going to be the same. Now, if I want to find the ratio of the areas of these two trapezoids, again, smaller to larger has been dictated for us. We're going to take that similarity ratio and we're going to square the numerator and the denominator. So now the ratio of areas is 4 to 9. So using that same idea, I'd like you to take care of number 5, find the ratio of perimeters and the ratio of areas if I tell you that corresponding sides have a ratio of 5 to 7. So the ratio of areas would just be that 5 to 7 ratio. That's also your similarity ratio. I'm sorry, that's ratio of perimeters. I think I might have said areas. Now the ratio of areas, you would square that similarity ratio and find that that is 25 to 49. Now actually using these, apparently I didn't hide the work on you. All right, let's try this again. Pretend like you didn't see that before, and now don't go back in the video and look at them either. So if we are given two similar figures, we might be asked to find missing side lengths, missing perimeters, missing areas, and using the idea that they're similar, we would use proportions in order to answer those questions and find those missing values. So here we've got two regular pentagons. The smaller one has an area of 27.5 square centimeters. Our job is to find the best approximation for the area of the larger regular pentagon. Well, if they're both regular pentagons, we know that all of the angles are going to be congruent, and an angle in one regular pentagon is always the same as angles in another regular pentagon. So these are always going to be similar if they're the same regular polygon. So in order to work through problems like this, in order to set up your proportions, first thing you should focus on finding is your similarity ratio. Now remember, to find a similarity ratio, you always are taking side lengths, one off of each, and setting up a. So to find the similarity ratio in number 6, I would take 4/10, and then reduce that to 2/5. So that's my similarity ratio. Now to set up a proportion, we have to remember we always have to stay consistent with our proportions. So in this case, I would start with my similarity ratio of 2/5. Notice I'm squaring it though, because this problem is dealing with area. So I have to use the ratio of areas, meaning square your similarity ratio. And then I'm doing small over large again. So area of the smaller shape over the area of the larger shape, which is what I'm trying to find. So now you would just cross multiply. And then when you solve, you would find that the missing area would be 171.875 square centimeters. Now again, it's an area, so you have to make sure you have your square label, or your label of using square units with your answer. In number 7, we're told that we have two similar parallelograms and we're given the ratio of 3/4. So that means our similarity ratio is already given to us. It's already 3/4. So you wouldn't necessarily have to find it in this case. Now, if we set up a proportion, again, since we're dealing with area, we have to make sure we square our similarity ratio within our proportion. And notice now this time the missing area is in the numerator because it's the area of the smaller parallelogram that I'm trying to find instead of the larger like in the last problem. So now again, cross multiply and solve. We would find the area here to be 54 square inches. Number 8 gives us, we have 13 bushels of vegetables harvested from a given plot of land. How many bushels can we expected to be harvested from another plot of land with dimensions 2.5 times the corresponding dimension of the original plot? So here, first thing you have to figure out, like normal, is the similarity ratio. But you're only given one number that deals with the dimensions. If you're ever given values of how much larger than an original or how much smaller than an original a certain dimension is, that's actually giving you your similarity ratio. So here we have a similarity ratio of 1/2.5. Whatever the original one is, that's the 1 in the numerator, and then the denominator is the dimension, or how many times larger the dimension of the new plot is. Now, if you think about when you're harvesting vegetables or growing vegetables, when you look at a field, a farmer's field, which we see plenty of here in Wisconsin, you should be able to understand that those crops are planted all the way throughout that field, not just around the edge. So that means this is an area problem. So when you set up your proportion, we again, since it's area, have to square that similarity ratio. So I have the original in the numerator. I have the second plot of land in the denominator. So the original number of bushels needs to be in the numerator, and then the new number that I'm trying to find in that denominator. Cross multiplying and solving here. The only thing to keep in mind here is now your answer that you're looking for is a number of bushels, so you need to make sure you include the correct label. Number 9, if you think about a piece of glass, this is also an area problem because glass does not just go around the edge. Glass fills an entire area of a certain shape. So again, similarity ratio is what we need first. We are told that in this case that it's 3/5. So setting up the proportion, again, it's an area problem, so we have to make sure that we square our similarity ratio. And then when you cross multiply and solve, you would find the new cost of $6.94. Again, keeping in mind, paying close attention to the label that needs to go on your answer. Whereas for a cost, we need to make sure our label is appropriate for a cost. And also, when you round, if you're dealing with money, you would only round to the nearest cent, not nearest thousandth, like we typically do. Now we have to be able to use our knowledge about ratios of perimeters, ratios of areas, similarity ratios to find a similarity ratio when we're given some information possibly about perimeters or areas. So the first thing we have here are two areas of similar triangles being 50 square centimeters and 98 square centimeters. And our job is to figure out the similarity ratio. So first thing we would do is we would set up our two areas in a ratio. So that would be the square root of 50 over 98. Now, 50 over 98 would be the ratio of the areas, taking the square root because we want to go back to the similarity ratio. Ratio of areas is always the similarity ratio squared. So to undo that squared, we have to take the square root, which means we're square rooting both the numerator and denominator individually. So now instead of using calculators for this, I strongly suggest that you just put these in simplest radical form like we've practiced. So that means we would have 5 square root of 2 over 7 square root of 2. And then just reducing this, those square root of 2's would be able to be reduced out. So we would just have 5 to 7 for our similarity ratio. 11 is the same idea as number 10, except now, instead of going ahead and taking the square root right away like I did in number 10, now I've set up my ratio of areas. One thing that you might always want to do, and this could have been done in number 10 as well. I just chose not to explain it in that problem, giving you a couple different options. Now I would maybe want to reduce. So I've reduced 1,875 over 135. I use my calculator if I need to, so that I have now a ratio of areas, still areas, of 125 to 9. Now I would take the square root of that to get it down to being the ratio of, the similarity ratio, which is the same as the ratio of the perimeters like we were asked for. So the square root of 125 I would need to put in simplest radical form, and the square root of 9 is just 3. So 5 square root of 5 over 3 would be that ratio of perimeters. In number 12, now we are asked to find different lengths of the sides of a triangle instead of finding maybe a missing area or perimeter. Now we're given the area of that smaller triangle being 6 square centimeters. So if we're given one area, if we look over here at the big triangle, we would need to find that area so that we have a value to compare with the area that we were given. So just using 1/2 base times height real quick, we would find the area of that to be 48 square centimeters. Now, we do know that these are similar because of angle-angle similarity. We have a 90-degree angle and a 30-degree angle. Now, we're not going to use 30, 60, 90 triangles to find any missing side lengths here. Those angles are just simply for finding why those would be similar triangles. So a couple ways you could go about doing this. First one, oops, not what I wanted to do, sorry. First one, we could set up a proportion using the areas of each triangle that we're given. So I did 6 to 48. Notice I have those labeled as areas. And if I'm trying to find x in this case, I would set up the ratio of x to 8. But since this left side of this proportion is dealing with areas, I have to make sure I square this right-hand side because this is kind of representing our similarity ratio right now. And the similarity ratio always has to be squared when you're dealing with areas. So next thing we would do is we would cross multiply. So we'd get 48x squared equals 348. Then we could divide. And now taking the square root of 8, we're going to keep that in simplest radical form. That would give us a length for x of 2 square root of 2 centimeters. So that's one way that you could go about finding missing lengths in a problem like number 12. A second option would be to find the similarity ratio. The way that you would do that would be similar to what we just did in numbers 10 and 11. We have the two areas of these, so what we could do is set those up in a ratio, reduce them, take the square root, and then rationalize, and finally at the end of this, we would figure out that our similarity ratio is the square root of 2 over 4. Now, once we had the similarity ratio, we could set up a proportion. But now we wouldn't have to worry about squaring anything because we're no longer dealing with areas. We have a similarity ratio and we have a ratio of sides. So this would just be a normal proportion, like if we were to think back to the original chapter where we saw similar figures. So now again, cross multiply and solve, we would find that x value would still be 2 square root of 2 centimeters. Now, the problem, we have to make sure we're reading carefully, also says that we have to find the value of y. So I did the same thing with y that I originally did with the x value. I set up a proportion using the areas. In this case, my side that I'm trying to find is y, so I have to compare that with 12 from the larger triangle. Again, making sure I square that ratio of side lengths, since this is area on the left. Now, if I cross multiply, divide, and solve, I would find that y is 3 square root of 2 centimeters. That could also be found using something similar to what I did here in the middle, the second method for finding x. I could set up the proportion square root of 2 over 4 equals y over 12, and if I were just to cross multiply and solve that, I would find the same y value. Okay, now a couple for you to try. 13, I'd like you to tell me how much would mulch cost to cover a 12-foot by 24-foot rectangular garden. In this one, you'd have to figure out your similarity ratio first, so you would want to compare small side or short side of the original garden to the short side of the larger garden, and then longer side to longer side. Both of those would reduce to 2/3, so we know that we have similar figures here. Now setting up a proportion. Since we're covering the entire garden, we're talking about an area problem. So that's why I have my similarity ratio squared. And then solving it, we would find that the cost would be $108. Again, make sure you have a correct and appropriate label. Number 14, we're given the similarity ratio. So your job is to find both the perimeter and area of the larger triangle. So this is going to be 2 separate proportions that you're going to have to set up and solve for this. So please find those 2 values now. When you set up a ratio for your perimeter, you can just use your similarity ratio, because remember, ratio of perimeters is the same as the similarity ratio, so you don't have to square it. So then when you cross multiply and solve, your perimeter that you should find would be 60 centimeters. Area now, you have to make sure you square that similarity ratio in your proportion. And then when you solve, the area would be 50 square centimeters. Again, double check those labels. Make sure they are correct and appropriate for perimeter and area.